just let's go quickly now this time because we are already a little bit behind. So I work at Lambda 3. I'm a developer and I'm lead projects with mostly .NET and Node. I've been a MVP for 11 years now. And if you need to get in touch with me, the easiest way would be to go through Twitter at Giovanni Bassi. At Lambda 3, we are a gold partner, and we've been doing Linux for since they start. Actually, the company is 10 years old, so it's really a pleasure to see .NET going to Linux and working well with Kubernetes and all this stuff. I've been working with these technologies forever, and Kubernetes is my day-to-day. So I'll be speaking from experience. This is not only a theoretical knowledge I'll be delivering here today. We also have a podcast. So let's go. Let's talk about Kubernetes, Helm, and Terraform. I'll be watching the chat if you have any questions. And I'll stop at the end of every section if you have questions to answer them. This is supposed to go on for an hour or so, and we do have time for questions. So let's start with Kubernetes. So why Kubernetes? If you don't know Kubernetes, the idea is just to give a quick introduction. So you can do development with containers in your machine, and you can host these same apps on the cloud, and containers are great. We all love them. This is a simple scenario where you deliver the app to a single host on the cloud, and you manually delivered it, and it's running, and it's great. And as you have more success, what happens is you're going to need more machines to host your application, and then you're probably going to have to put a load balancer in front of these applications, and you're going to have to manually deliver these applications to several hosts, or maybe build some automation to do it for you. But this starts to get tiring as more machines are delivered, as you have to provision these machines. You have to manually provision the containers later using Docker, most likely. So this is probably going to be kind of tiring. So what you do is you move on to Kubernetes. Kubernetes actually won this orchestration war that we had a few years ago, and Kubernetes is the de facto standard for orchestrating containers today. And Kubernetes does all this for you. It actually takes care of the machines and takes care of running the containers, and then it takes care of all the networking and file access, all the storage access. So it's great. It adds a little complexity, actually not a little, adds a lot of complexity, but it's actually better to manage it this way than managing the individual containers and hosts. The problem is that if you do that manually, again, using VMs, you're going to have to actually take care of the infrastructure, installing Kubernetes yourself and managing the hosts and the nodes where the workloads run. So it's a lot of work and demands a lot of knowledge, because you have to know how to manage the database, the Kubernetes database, which is actually an etcd database, and you have to be very careful. You're going to have to pay for these hosts for managing the cluster and everything. So the idea here is let AKS manage the cluster for you, and you don't actually need to manage the infrastructure of Kubernetes. You only run Kubernetes and let Azure take care of it for you. So you demand a certain cluster size. It can auto scale if you'd like it to, and you actually only you actually only use Kubernetes. You don't have to manage the infrastructure of Kubernetes. So you don't actually need to provision the machines. You don't have to back up the hosts databases, the admin databases for Kubernetes. You don't have to worry about any of the infrastructure. If the cluster goes down for some reason, Microsoft is supposed to take care of it. We don't have to manage anything. Okay. The day-to-day operation of Kubernetes you still have to do, but That's much easier. So you are a level above. This is actually a platform as a service offering, okay? And I'm actually showing here ACR. ACR is the container registry from Azure. And it's actually very common to be used with AKS. So that's what your setup would most likely be. You have AKS taking care of the whole Kubernetes infrastructure and ACR taking care of the container images, and later on we'll see ACR also taking care of the Helm charts. Kubernetes will ease the deployment, management, and operation. It can do self-healing. If the cluster has a problem, it self-heals. If you need to upgrade the cluster versions, it will also do that automatically, which is a lot of work, and it takes a lot of knowledge to be able to do it yourself, and you don't have to worry about it. You actually just instruct it to go from one version to the other, and it does that. You can easily scale it. It actually understands the need for from Kubernetes to scale out. So as Kubernetes creates more containers, AKS can actually provision more machines for you to take care of that extra workload. It can help you go to use containers faster, because creating an AKS cluster is as easy as going to the Azure portal and going through the steps. It's not that many steps. You can also do it from the command line if you want. Everything from Azure you can do from the command line. It's actually an open source Kubernetes, a certified Kubernetes, so you don't need to worry about it being a Microsoft Kubernetes. That doesn't exist. It's actually just another Kubernetes integrated into Azure. And all the open sources, tools, and APIs you already use, you can continue using with KKS. And it's really easy to set up CI and CD, especially if you are using Azure DevOps or GitHub. It's really simple. So this is how a cluster with Kubernetes would look like. You have a control plane with master VMs, and you have an agent pool with nodes, or they used to be called minions. We call them nodes today, and the nodes are the ones that actually run your applications, and the masters, they only run the cluster administration, right? So if you were to manually run Kubernetes, this is what you'd have to do. The recommendation is to go use at least 3 machines for the master. Some people use 5, some other people use 7 to be more safe. But when you are on AKS, you actually don't have to worry about that, because Azure has a hosted control plane, and you don't actually get to touch these machines. They are hosted. They are somewhere else, which we don't have access to it, and you don't have to pay for it as well. The hosted control plane is free, so those 3 or 5 or 7 machines, they are actually unnecessary, and you don't have to pay for them. And the only thing you pay for is the machines that are on the agent pool. You can have more than one agent pool, and they can be specialized machines. So you could have a agent pool with large machines, and another node pool with smaller machines, one node pool with Windows, another one with Linux, and they can actually, when you publish the application, Kubernetes will know where to deploy the workloads on the correct agent pool, if you actually inform that on the objects you are deploying. So this all works really well. And there's also another option, which is to use the ACI connector, which uses an open source project which is called Virtual Kubelet. This is on GitHub as well, and they are using this open source project to integrate AKS to ACI. ACI is the Azure Container Instances. It's able to run containers, not orchestrated containers, only standalone containers. But when you integrate it with AKS, you actually get a new machine. It actually mimics a machine. It works as if it was a really big machine where your containers will run. and it is completely integrated with the rest of AKS. So in practice, what you need is they ask you to have one of these orange machines, one node, and because that's what you pay for actually. So you, at least for that you have to pay for. But all the other workloads can run on this ACI or on ACI, and you only pay for what you are actually running. And ACI has a really nice pricing model where you pay per second. It's very granular, and if you run, for example, a container for 20 seconds, it's twice the price than if you had run it for 10 seconds, for example. So this is supposed to be, you can actually have a serverless Kubernetes if you do it this way. You only have to have one node, and all the others go through ACI. Some quick concepts which are part of the Kubernetes world, and it's important to know. So I'll go through this really quick, so you actually can understand what they are. So a pod is actually an abstraction around containers. A pod can actually contain more than one container. It's actually a isolation boundary, and it can actually include more than one container. So it's very common for you to have two pods two containers in a pod, where the main container runs your application, and you have a sidecar. It's called a sidecar, which does something accessory to that main container. The containers that are inside a pod, they share the network namespace, so they can talk to each other really cheaply using localhost. And it's actually the main concept in a Kubernetes cluster. The service is the way you expose a container to the rest of the cluster or outside to the cluster, and a service can route requests to several pods. And a deployment is a way to provision pods that's very resilient, because a deployment can you can scale the pods. So you can, for example, say you want 3 pods in a deployment, and it will actually take care of deploying and taking care of those pods. If one of those pods actually dies, the deployment will spin up a new pod. So this is the recommended way to deploy most of the applications. Is instead of deploying a pod, you deploy a deployment which will actually take care of the pods. An ingress is a resource that is able to take care of routing traffic from outside the cluster into the cluster, and a service can actually do that as well, but an ingress is more flexible, where it, for example, host a domain name and route, for example, paths or subdomains to specific pods. The most common way to do it is using an Nginx ingress controller. And then on every deployment, you configure an ingress to work with that ingress controller. So it's a way to have, for example, one single host with several pods. A config map is the way to configure a pod, so there goes your configuration. And secrets is also a way to configure a pod, but the values are secret. And you have service accounts which plug into the role-based access control from Kubernetes. Kubernetes, it's native. Kubernetes has a native RBAC environment, which is usually turned on by default. And service account is the way to interact automatically with the cluster. So every pod usually has a custom service account. If they don't, they actually inherit that from the namespace where they run, and that's a concept I actually didn't mention. You have logical boundaries inside Kubernetes, which are namespaces, and all these resources I just discussed live inside a namespace. And this is actually how you orchestrate the whole concept. You can see how this is actually much more complex than running a single container, but this is also much more powerful. So I'll do 3 demos in this presentation today. The first one, I will show you a demo creating a Kubernetes. This one actually is using a script, which I will link in the end, and you can try it yourself. I will run a single pod, and I will try to access it. And to avoid unnecessary problems I might have, I actually already recorded this. So I'm gonna play it, and I'll stop between the presentation, and I'll explain what's happening. So this is a single script that's running. I actually every line is showing the command that's running, and I'm also counting the total number of seconds that it's taking to the script is taking to run. And so we are going to run a single pod, and we're going to expose it with a service and see how this impacts AKS. Okay. So here I just created a namespace with this command, kubectl kubectl create new namespace. Hello. This is how you interact with Kubernetes. It's using this command line tool. You can also use an API. This is less common, but people also do it. So it took me 1 second to create the namespace because it's actually a logical resource. Then I'm going to actually create a deployment using this image. It's a public image from, it's hosted on Google's container registry. And it took only 2 seconds to create the deployment, 2 more seconds, right? And then you can see that the state of the deployment, that you have one deployment with 1 pod deployed, but no pods ready. It's 1 second of age. And here you can see the pods. I'm getting the pods, same information. And then getting the events, you can see the pod was scheduled. Then, oh, you can see my screens. Sorry about that. Oh, you can't see. We can see my. Can you see my screen or not? Please help me, because you were supposed to be seeing my screen. Please tell me on the chat if you can see my screen. Hello there. Can you see my screen? Oh, I'm assuming you can see it, so I'm moving on. I hope my audio is not delayed, but let's go ahead. Yeah, it's supposed to be okay. Okay. So here you can see the events from the pods. So you can see the pod was scheduled and then successfully created, and then scale the replica set, which is an internal concept. You can also interact with it. And then let's go ahead. Then I'm exposing the deployment. This actually creates a service, and I'm saying you have to use a load balancer. I'm actually exposing on this part, so this took only 3 seconds. Then I'm waiting on the pod to be ready. This actually I cut the video, so it actually took 14 seconds for the load balancer be exposed, and then I'm trying to get the service, and actually another 10 seconds to be able to get in touch with the service. So 24 seconds total to be able to talk to the service, and then the script stopped running, and then let me just go back here real quick. You can see when I curl that I actually got the response from that container. Now we are gonna interact a little bit more with the cluster. I'm showing you here the nodes, and you can see the nodes, and we can describe the nodes and see how much memory they have and how much CPU they have left. So this is a really small cluster. It only has 1 node and very little memory, but you can see here it has half of the cluster requested and 16% of the cluster memory in use. And now we are going to go to the portal and see these resources in the portal. So here you can see the node pool, and you can see it's only one machine. And you can scale the node pool. You cannot scale it directly here. You can scale through the node pools. You can use dev spaces if you want. If you want to enable that, is as simple as changing that value. Here you can see the metrics for the containers, and you can also see the pods. And you can also, let me go back so you can see the metrics real quick. This is on Azure Metrics, and you can see here the pods, number of pods that were running. And then you can also see the resources that are under the hood. So these resources, they are actually what Kubernetes creates when you request new things. For example, here you can see the load balancer created down here, and you later on you're gonna see disks also created on the next demo I'm gonna do. So this was this first demo. If you have any questions, you can bring them up on the chat now. Let me see if you have any questions, and I'll be able to answer them. If not, we'll go ahead and go to the next section where we'll talk about Helm. Let me see. No questions so far. I can see I have about 10 or 20 seconds of delay because the last time I asked if you could see my screen. So I'll just give 10 to 15 seconds and see if you have any questions. And if you don't have any questions, I'll move on to the next section. Just a few more seconds. If you don't have any questions, we'll go on. Okay, no questions so far. No questions yet. So, okay, it seems that it's clear to everyone. If you have any questions later, we can stop on the next section, and you can ask your questions about Kubernetes there as well. So let's go and discuss Helm. Helm is a Kubernetes package manager. You can actually, instead of package manager, think of a application package manager. So you can deploy applications to Kubernetes using Helm. It's if you use .NET, think of it as NuGet, or if you use Node, think of it as npm and other. It's a package manager. Okay. It produces the only artifact you're gonna need on after a build. Actually, you're gonna actually need the Docker image as well, the container image as well. But those would be the main artifacts. And you can see other apps, already made apps on hub.kubeapps.com. This site actually aggregates lots of different apps, okay? And you can easily install them. For example, things like WordPress or SQL Server are some of the examples you can deploy. You can find, let's encrypt integration apps. For example, there's a very common one used called Cert Manager. So all sorts of apps are available on hub.kubeapps.com. The way it works is it has several YAML files because YAML is how Kubernetes interacts, how you interact with Kubernetes. And what Helm does, it actually tokenizes a few YAML files. It has a template language that you use. And then when you are done creating all these resources, these Kubernetes resources, you create what we call a chart. A chart has a YAML description file as well. It's called chart.yaml. And there you describe your chart and your dependencies. And after you can package this whole chart into you can package the chart in a chart package and publish it to a chart repository. A chart repository is actually a Docker repository for the most modern repository hosts. For example, ACR already is able to host Helm charts, and actually any repository that's using registry v2 from Docker is able to host Helm charts. Helm charts are actually able to publish any Kubernetes resource because they are only YAML files, and all you do is you create a templated YAML file. So it's much simpler to organize your work around the Helm chart of the releasing a Helm chart, then having to manually deploy all these YAML files, the pod YAML file, then the service YAML file, then the service account YAML file. You package it all inside the chart. So it's much less complex to release. It's very easy to update. You actually get releases stored on the server, on the cluster, so you can easily see what you have released, when you have released, and you can easily also roll back. And it's also really easy to share your chart with other people. So what you do on your DevOps pipeline and DevOps instrumentation is you actually store your chart on a container registry. You actually build it during your build pipeline, store it on the registry, and then when you're releasing, you actually pull it from the registry and then release it to the cluster. It's actually super simple. And if, for example, you have some problem, it's really easy to roll back. With one simple command, you can go back to a previous version or any previous version you want. So what happens is, this is the same image from before, but now you have the ACR registry also storing Helm charts. And if you are using Helm 2, you need a registry server component, which I'm showing here. But if you're on Helm 3, you don't need this server component, and the whole thing is much easier to manage. So I recommend you to go and use Helm 3 already if you're not using Helm yet, and don't use Helm 2. And the Tiller component it used before, Tiller was the server component from Helm 2. Okay, go to Helm 3. Helm 3 is a 100% client tool. It doesn't depend on anything from the cluster. You don't have to deploy or prepare the cluster in any way. Okay, so I'll do a demo now for Helm 2. For Helm, because the process for Helm is actually the same process for Helm 2 and Helm 3. So what you see here is I just created a namespace for WordPress, and I'm deploying a chart called stable/WordPress, and I'm setting my password. This is one thing I actually didn't mention. Charts are, they can accept arguments, so you actually have one chart, and you can use the same chart to multiple environments and multiple scenarios. You can have one chart that's used, for example, on the developer machine to validate if it's working, for example, and you can use a different chart for the shared development environment, or later for a staging environment, and later on for a production environment. You only change the arguments. So it's really flexible, and that's the reason I actually have the templated YAML files. I had forgotten to mention that. So then after this, the deployment will run, and here you can see that the release notes. You can see that the WordPress chart has some interesting release notes where it tells you how you should interact with your new WordPress deployment. I chose this WordPress example because it's interesting, because it actually deploys a web server And it also deploys a database, a MariaDB database. And this database is password is provisioned through this argument here, and is actually passed on to the WordPress website that uses the database. It's also really interesting because both the web workload and the database workload demand a disk, because WordPress needs a disk. It actually stores a lot of information on disk. So you are also going to see the disks that were attached to this release, this Helm release. So you can see here, I'm just going to copy these values and paste it on the command line. And you can see here the URL, which was gotten on this environment variable, actually on this, and then later on showed here, and also the admin URL. So we're just going to access it later on. First, let's see if the pod is already ready. It's not ready yet. It's running now, but not ready yet. It only will serve traffic when it's ready. Now it's ready. And we are going to access the WordPress deployment, and there it is. Hold on, that was really fast. let me go back a little bit. Here is the WordPress running. And then I'm going to go to the admin website and log in with the full password. And this is the admin WordPress URL. Things are going really fast, but it's actually running there. So you can see here. And then we're getting the persistent volume claims. These actually are claims to the persistent volumes. And you can see, let me go back real quick. You can see here we have one 8 gigabyte disk and another 10 gigabyte disk, and one is being used for MariaDB, MariaDB, and the other one for WordPress. Okay, and you can actually see them on the portal. So there they are, and they are actually. Let me go back a little bit just to talk about that real quick. You can actually see these persistent volumes. They are actually Azure disks. So this is what happens when you create a persistent volume on Kubernetes. Actually, when it's running on AKS, to actually provision these disks, and you don't actually have to do anything. Kubernetes to Azure integration does everything. So I'm going to delete the release right now, and it's now uninstalled, and the pods are dying now. They're terminating, and so is the persistent volumes. One is gone already, and the other one should be gone real soon. Let's see. And I deleted the other because by default, if I remember correctly, it doesn't delete the MariaDB database. And I'm just impatient here trying to see if it's already deleted. I'm going to refresh it on the portal, and the first persistent volume is gone, and now the second one is gone as well. So this is, you just saw now the Helm release, provisioning the pods, provisioning the service, and provisioning the persistent volume and the persistent volume claim with a custom value for the password. And then you saw the AKS provisioning these resources on and then you saw these resources on the portal. So if you have any questions about that, I can answer them as well. I can see a question from Karthik, Rishi. How do we see Helm packages published in a private Azure container registry? When you access a container registry, they show up as repositories, just as normal Docker repositories, container repositories. They are not actually container repositories. Their internal structure is a little bit different, but they show up there as well. So they're just repositories. And Azure, actually Docker Registry v2 is able to host anything if you respect their base structure. So you could actually, for example, host npm on Registry v2, or NuGet on registry v2 or anything you want. Okay, and what Helm does is actually use the same infrastructure to provision its charts. Okay, so on Helm v3, you now have a way to interact with these repositories that was not available on the registry on the Helm v2. Okay, Helm v2 had no idea on how to publish and grab Helm charts and Helm repositories, and Helm v3 already has these concepts. Okay, so before Helm v3, you had to manually, using other technologies, you have to publish the repository and then get it back to your machine. And using Azure, you actually used AZ, the command line tool, to publish and bring them back. You can still continue to use that, but now with Helm v3, you can directly interact with the registry without depending on the AZ command line tool. Well, I can see no more questions, so we are going to move on to the next section and talk about Terraform. Again, if you have questions, you can ask them and I will answer them in the end now. So what is Terraform? Terraform is the way you provision all these resources to Azure. Okay, so Azure Container Registry and Azure AKS and other resources you want. Okay, the thing is you're gonna do it in a way that you're gonna save the configuration and be able to really easily share this configuration with your peers and evolve all this infrastructure really easily. So Terraform is actually one of the best ways to work with infrastructure as code and one of the easiest ways to do it. You actually write the resources you want, then it can plan and show you the plan so you can see if that's what you need, and if not, change your resources and plan it again until it's the way you want. And then you commit this plan usually on a Git repository. That step is actually you can skip that step and you can work on files on your machine. I don't recommend it, but you can do it. And then you actually deploy, then you actually deploy this plan to Azure or to anywhere else, because Terraform can talk to your local infrastructure. For example, if you have VMware installed, you can integrate Terraform with VMware or any other cloud. It's really, really flexible. It has some Hyper-V extension points as well, if I remember correctly. So it's really, really flexible. So it's going to abstract over different resource types, but it's not going to abstract too much. For example, it doesn't have the concept of a VM independent from the infrastructure. It doesn't have a generic VM. It has the concept of a Azure VM. If you had a VM on other cloud, it would have the concept of the specific for that cloud. So you cannot actually declare a abstract VM and deploy it to Azure. That wouldn't work. It's actually really dependent on the infrastructure it's connected to. You usually will do very reproducible builds. So once you deploy a script to Azure using Terraform, if it works, it's always going to work. And you can actually build a deployment pipeline with tests and etc., validating all everything that you are planning to deploy later. So you can actually build a whole deployment pipeline for your infrastructure. It's extremely simple to use as a failover. So if you can imagine a situation where your main data center goes down, and you can grab your Terraform scripts and point them to some other data center and deploy, and it's going to be just bring up your resources just really fast, as your cloud is able to provision them, and you can prevail over real fast, really easily. Terraform actually has the concept of different environments. So you can actually have, for example, your main environment deployed, and you can change for a different environment and publish it without changing changing much. You can simply instruct it to use a different environment. It will simply then deploy to the other data center, for example. Okay, it's the real one-click publish for infrastructure. Deploying a Terraform is as simple as running a single script, and it's done. Okay, so it's really cool. And these are some of the Azure resources it can interact with. This is not a complete list. This is just a quick list to show you some of the things it can do. I actually took this image about a year ago. So it has many more resources today. And you can actually follow up with the resources it's controlling. It's able to control on its GitHub repository, and they are publishing new releases with new resources every 2 weeks or so, if I remember correctly, but it's evolving really fast. So it gives you a unified workflow that you can use independent of the cloud infrastructure you are using. And this is an example of a resource. So this is actually an AKS resource. So this is how you define it. It's a weird markup language. It's not JSON. It's not YAML. It's not XML. It's something else. It's weird at first, but you get used after a while. Here you have, you're defining a resource. This is the first part. The first string here is the type of resource you are deploying. The second part is the name of the resource. Here is you're defining the name for this resource. Actually, it's a property named name, right? Because internally the name is this one. This name is going to actually be used to define the name in the cluster. And it's using a variable to define the cluster name and a random number. I'm going to show you the random in the next slide, how you do a random in Terraform. The location is also a variable. This ensures that all your resources are on the same Azure data center and the same location. Here's the resource group name. I'm not showing here the resource group, but the resource group is another resource. It's in another file. So it's referencing the resource group from somewhere else. So here you can see a reference to another Terraform resource. So you can have all this web of connectivity between the resources. So because of this, the resource group resource will be deployed before the AKS resource, because the AKS resource depends on the resource group resource. Here, you define here the DNS you want, and the profile for the machine, and the size of the machine you want here on the agent pool profile. So here is a standard D2S V3. It's a Linux resource, and they use 50 gigabytes of storage, and this is how many you want. So this is how you do it. This is a really simple resource type. AKS can go much further. It accepts much more configuration. This is the simplest you would do. This is a random, so this is actually an internal thing. You can generate random numbers. Terraform has other internal resources you can use. This is just an example. You can have several types of randoms. This is the one named Kubernetes. Once you run a plan, this resource is ran, and then the value that it generated shows up, and it's available to be used for all the other resources. So usually it's the first one to be created because all the other resources depend on it. So I'll do now a quick demo on Terraform, and after that you can post your questions. So I can see I have a small delay. It's 20 to 30 seconds. So if you have questions on what you're seeing, please post them on the chat on YouTube, and I'll then later on I will come back and answer your questions. So this is actually running from Windows. The previous ones you saw, I was running on WSL, actually on Windows as well, but it was actually Linux on Windows and running Bash. This is actually Terraform on Windows, automated by PowerShell using Sake. Okay, so I'm running a few tasks, some few tasks here, and I'll stop in the script so I can explain to you what I'm doing. This demo is about 1 year and a half old, but everything I'm showing here is still true. Terraform is 0.11 has been updated. The version I recommend you to use is 0.12, but for the demo purpose here, nothing changed. Everything is the same. Docker 18.09 is very recent as well. Nothing changed. And Kubernetes 1.13, that's a little bit old, but that didn't change anything for the purposes of this demo as well. So I'm gonna first create this infrastructure, and I'm ensuring I have the tools I need. This is the first part of the demo, and then now you're seeing Terraform showing its plan. So you can see Terraform planning here. It's showing you what it has planned. So the plan is ready here, and it's saved to a file named out.plan. Okay, it took like a few seconds to do it, but it's actually real quick to do it. It actually goes on to the infrastructure and see if it needs to create something or change something. This is accelerated. It's actually creating the resources now. You can see now that Cosmos DB is ready. I'm provisioning Cosmos DB as well here on this example to be able to interact with the app. So here is Cosmos DB ready in about 5 minutes. And then I'm provisioning a small cluster. Small clusters take a little bit longer to be provisioned. And it took about 12 minutes. Usually, if you have a larger machine, you take about 5 to 6 minutes to provision the cluster. It wouldn't take so long. And here is the data from the cluster, right? After you are done, Terraform will show you all the values it created, and you can actually asking Terraform to get this data for you, because the data is actually saved to a local file on your machine and optionally shared with your peers on a storage backend. And if you're on Azure, you can use Azure storage, okay? But you can also use other types of storage, including a paid Terraform storage that HashiCorp, the maker of Terraform, offers. And actually, Terraform is all open source, so but you don't have to use anything from HashiCorp. But I recommend you support their work because they are great, but they don't charge anything for any of these tools. And here you can see so the values from after provisioning the whole thing. And now I'm actually interacting with the cluster using Helm. So I'm actually in deployer. This is Helm 2 actually. As I told you, this is a year and a half demo. So I'm actually provisioning the Tiller server-side component for Helm to be able to interact with Helm later. So this was it. Then I'm provisioning the Nginx ingress into the cluster using Helm. So here again, a new release from Helm and all the information from Helm there. Then I'm actually interacting with creating a new release using the Cert Manager chart. This is able to talk to Let's Encrypt and provision SSL certificates so my applications can use it. So you see here that in under 20 minutes, we were able to provision a Kubernetes cluster, provision a Cosmos DB instance that was done in parallel, then provision the ingress and Let's Encrypt resources. So at this point, I'm able to start deploying my application to my cluster using a secure certificate, and all the Kubernetes infrastructure I need. If you use only one virtual machine for your cluster, you are only paying for this one virtual machine. Azure doesn't charge you for anything beyond that. And that's how you do it in under 20 minutes. So this is the type of script I recommend you build it. You build on your company, and you actually take the scripts further than and create a whole build pipeline for your infrastructure later. And don't use the terminal directly. Always interact it, with it using a build pipeline. So I'm ready to take more questions. We have a few more minutes for your questions. So if you have any questions, you can ask them on the chat, and I'll answer them. And it seems that we already have a few here. Mitch is asking if Terraform is the same as Ansible. In some ways, yes. I'm not an Ansible expert, so I can't go much deep on that. But I can actually say they actually some of their what they do is very similar. But the idea here in Helm is in Terraform is that you have a declarative way to provision your resources, and you need 0 agents running anywhere. Everything from Terraform runs from the client, and you don't need to provision a server or a agent anywhere. Everything is provisioned from the client. Okay. If you need more information later, you can go to these resources. So this in the corner here, down on the right, is the script I ran on the first demo. If you wanna run it yourself, and here are all the other resources you may need. I find it really interesting, this AKS tutorial you can use, so you can go step by step and learn AKS. Here are the docs for AKS if you need them, and announcements are usually on GitHub. And here are the resources for Terraform, Help, and the apps for Kube apps, for the charts, for the public charts. Do you need, if you have any more questions, I will be able to answer them in this few minutes we have left. And if not, if you remember anything later, please get in touch with me on Twitter. I'm always on Twitter. It's the social network I'm most on. So if you have any questions later and you need to clear them, feel free to contact me. My direct messages are open, so you are open to ask them privately if you want. If not, you can also ask them publicly so other people can get involved and also discuss the issue with you. I can see another question here from Karthik. Where do we provide access right in Azure for Terraform to provision resources? This is actually a very good question. So I'll open here the web page for Terraform Azure, and you see that where you do it. It's really simple, actually. All you need to do is one of the resources you provision actually informs that. Let me see if I can find it here. Let me see if I find it here. It's actually really simple. Azure Resource Manager. It's like here it is. Let me see. No, it's not that. Let me see if I can find it. It's actually it's actually a resource where you put your I won't find it right now, but authenticating here. So this is one way of doing it. You actually log in with AZ. You can log in with AZ, and Terraform will understand that. And the one I've been using AZ and a service principal. So you can also use a service principal by providing the password and the tenant here and the app ID. So this is how you do it, for example, using a build pipeline, for example. Okay. And you can also, if you're using it directly yourself, you'd use on a resource like this. So it's actually super simple to do. Let me see if we have any more questions. If not, we will end this presentation. Let me see here. Okay, it seems we don't have any other questions. So thank you for participating. And if you need to talk to me later, you can always contact me on Twitter. This is it. I'll see you later, and bye-bye.